the table shows the relationship between weekly total sales in dollars and the number of different rug designs the store contains. So here's your table. The first part of the problem says, write a regression model that best fits the data and round your answer to the nearest hundredth. Well, right now we don't know what type of regression model to use. So we don't know, does this data best fit a linear model, a quadratic, or a cubic? So again, grab your calculator. Please do a second plus 712. And we're going to start by plugging in the data. Remember, after you hit stat and you press enter, you have to have L1 followed by L2. If you don't, just grab a different calculator. So please plug in the numbers from the table. $10, $20, $50, $5,000, $9,000, $18,000, $25,000, $32,000, and $40,000. Okay, so what we need to look at is we need to look at the range from the top to the bottom for our X's or our L1s, and for our Y's or our L2s, the top to the bottom. So please go to Windows. I want to go somewhere above this and somewhere below this, just to make sure that this data point is included in the graph. So I'm going to go from 0 to 150, to somewhere below 10 and somewhere above 130. Now go to Y minimum. I'm going to go somewhere below 5,000 and somewhere above 40,000. So I'm going to go from 0 to 50,000. These are not set numbers, it's just somewhere below and somewhere above the lowest and the highest number. My goal now is to look at these data points so I can tell, do they best model something that's a straight line, linear, that's quadratic like a parabola, or a cubic model? So to do that, hit the second key and hit scatter plot. Right now it'll say off. Press enter twice. It's on, and now hit the button that says graph. When you look at these points, do these points appear to best fit a linear line, a quadratic, or a cubic function? Okay, that's the first goal. That helps us to do part A. So I know that I want to use a linear model. So leave this here. Please hit stat. Go to calculate, go down to linear regression model. And in my calculator, I only have to hit enter twice. You may have to hit enter a few more times. And this says to round to the nearest hundredth. So we are creating an equation. Y equals 287.21x plus 2831.05. Bless you. This is my regression model, linear regression model, that models this data. In the past, and I mentioned this on Monday, students were concerned because they said, if I plug in 10 for x, I don't exactly get 5,000, or if I plug in 20, I don't necessarily get 9,000. Remember, this is an average of these points, so it's not going to be exact. Okay, here's your next question. So part B of this problem, let me move this forward. Okay, give me 1 second. What is the total sales when the number of designs a store contains is 90? What is the total sales when the number of designs a store contains is 90? So we're given 90, and 90 is associated with the number of designs. And the number of designs is an X value. So I know what X is. I want to know what the total sales is. I want to know what Y is. When you're given X and you want to find y, it's a little bit easier. So I'm going to take this equation, and wherever I see an x value, I plug in 90. So we can estimate the total sales would be $28,679.95 when there are 90 different designs at a particular store. Your third and final question. In this problem, we want to know how many designs. So we want to know what is the x, and we're given the total sales. We're given the y. And so to do that, you learned how to do this back in August. Go to y equals, and let's start by plugging in our regression model. So this models the data, and now we want to know what is x when y is 7,000. When you're done, hit graph. Okay, and we want to find out exactly where do they intersect. So we're going to go second, trace, intersect. And I can see down here, does everybody see how it's hard to see? How this goes in front? So I'm going to go to Windows, and I'm going to go down here. So I'm going to go down to maybe -20, and maybe down to -20,000, just to give myself, I'm just moving those x and y minimums down so that when I find this intersection point, it's not covered up by the numbers below. Second, trace, intersect. Okay, so let's find the data point here. Okay, so the first linear line as it rises up to the right is my first curve in this case. Press enter, it jumps to the horizontal line. Press enter, go over the top of where they intersect. And it appears like there is 14 and a half designs. Well, can you have a half of a design? So, it's approximately 15. Now, if it doesn't tell you how to round, I would accept either 14 or 15 in this case if it's not specific about how to round. Okay? So for this question, when the total sales are 7,000, there's approximately 14 or 15 different designs contained at this particular store.